Have you ever noticed how the world seems to, well, follow certain rules? You know how some things move together in perfect sync, while other things are complete opposites? It's not magic, it's math. And today, we're going to unlock the secret code that explains these relationships.
Just think about it for a second. When you're shopping, the more stuff you put in your cart, the more money you pay. That's simple, right? But when you're driving, the more speed you have, the less time it takes to get there. So they're both totally predictable, but they work in completely opposite ways. What's the hidden rule that connects these two ideas?
Well, that secret rule has a name. It's a concept in math called variation. And all it really is a way to explain how two different things are connected, how a change in one thing causes a totally predictable change in another. You could almost call it the language of relationships, just told with numbers.
Now, to crack this code, we're going to need two keys. So let's start with the first one, direct variation. This is the key that unlocks any situation where two things change in the exact same direction.
The logic here is really simple. When one thing increases, the other one increases right along with it. And if one of them decreases, its partner does the exact same thing. They're just perfectly locked in step.
And here's the math that proves it, the magic formula, if you will. If you take your two quantities, we'll just call them x and y, and you divide one by the other, the result is always the same number. That special number is called k, the constant. It's the unchanging secret that links the two together.
Okay, let's look at this table from our source. 8 articles cost 40, 10 cost 50, 60 cost 300. You see the pattern? In every single case, if you divide the cost by the number of articles, you get 5. Every single time. That is our constant, k. The price per article is totally fixed.
And this quote from our source really just sums it all up perfectly. That constant ratio is the ultimate proof. If you can find that k, you've officially found a direct variation.
All right, we've got our first key. Now it's time for the second one, which unlocks all those situations where things behave like, well, total opposites. This is inverse variation.
And honestly, it's really this simple. Direct variation is a more gets you more kind of deal. Inverse variation? That's a more gets you less relationship. They are perfect mirror images of each other.
The official definition basically just confirms this. An increase in one thing causes a decrease in the other, and the other way around. As one side of the seesaw goes up, the other side has to come down. And listen, this is the crucial difference, so pay attention here. The formula actually changes. For inverse variation, you don't divide the quantities, you multiply them. It's their product, x times y, that always equals our constant k. And you see this principle absolutely everywhere once you start looking for it. The faster you drive, the less time your trip takes. The more people you have painting a fence, the less time the job takes. It's this fundamental trade-off that's just built into how the world works.
So, we have our two keys. Now it's time to actually use them to open a lock. We're going to tackle a word problem using this really clever technique from our source called the arrow method.
Okay, here's our challenge. A crew of 78 men can finish a certain job in 140 days. But what happens if that crew gets smaller, down to only 42 men? How long is the same job going to take them?
Now, the very first question you always have to ask yourself is, what kind of relationship are we looking at here? Are the numbers going to move together, or are they going to move in opposite directions? Take a second, think it through.
You got it? It has to be inverse variation, right? Fewer workers means the job is going to take longer. As the number of men goes down, the number of days has to go up.
This arrow method makes solving this so much easier because it's visual. First, you set up two columns, one for men, one for days. Then, since we know it's an inverse relationship, you draw one arrow pointing down and the other one pointing up. These arrows are literally your guide to building the right equation.
And here it is in action, straight from the source. The arrows tell us exactly how to set this thing up. We follow the first arrow from its tail to its head, and we set it equal to the second arrow, again, from tail to head. It's just a simple, brilliant visual shortcut. So once we do the simple math that the arrows helped us set up, we find our answer, 260. It will take that smaller crew 260 days to finish the job. Our logic was totally sound. Fewer men meant more time. You know, understanding variation isn't just about passing a math test. It's kind of like gaining a superpower. You can now start to see the hidden mathematical patterns that are quietly running the world all around you. Think of this as your ultimate cheat sheet. Everything we've covered all in one place. How the relationships work, their unique formulas, and how the arrow method applies to each. The entire secret code is right here.
And like our source points out, this isn't just some abstract theory. It's a really practical tool for making sense of your daily life, from what's in your shopping cart, to your travel time, to pretty much any project you take on.
So, I'll leave you with a challenge. Once you start looking for direct and inverse variation, I promise you'll see them everywhere. In economics, in physics, even in your own kitchen when you're doubling a recipe. Where will you spot these hidden rules at play next?